Good afternoon to all of you students. Today I want to discuss about the calculation of velocity of sound through the gaseous medium. Calculation of velocity of sound through gaseous medium. So when you consider the sound travel through the gaseous medium like air, then air is supposed to be the collection of layers of air in this way. And when sound travel through it, sound will come at this point, then these layers of air are compressed and finally all are collected at this point. Similarly, again sound travel, then these are collected at this point. So this point is called rarefaction, and this point is called compression. Compression means the point where so many layers of air are collected. That is point B, and this is point A. Rarefaction, that is, the space will become vacuum due to sound wave travel through the medium. Then it gives force, then it exerted force on the layers of airs. Like sound is energy, energy is equal to work, work is equal to force into displacement. So if S displacement is equal to 1, then energy is equal to force. It means, I want to say, if sound is energy, then this energy must give force on the layers of airs, and this will become in this way. The first situation is this, when no sound travel through the medium. Second, when disturbance is created, then there is redistribution of layers of air. So if, first of all, we suppose the gaseous tube of transverse plane A and B is kept at the distance from the origin is x, and x plus delta x, x plus delta x. Then if this cross section of the tube is 1 meter square, then volume of tube AB is equal to delta x multiplied by 1. This is equal to 1. Equation number 1. Finally, we can say if sound is travel from left to right, that is along x-axis, then due to propagation of sound, this tube is displaced. Suppose A going in the position of A dash and B is going in the position of B dash, and this distance A displaced by the distance y and B displaced at the position of B dash, that is y plus delta y then the length of the tube is calculated as x plus delta x plus y plus delta y minus x plus delta x plus y. And this can be written as, so volume of the tube will become delta x plus delta y. This is equation number second. Again, yes, student, if initial volume of the gaseous tube is equal to delta x multiplied by 1, and by the change in the position of tube, gaseous tube A dash B dash, then its volume will become delta x plus delta y, then change in volume delta V is equal to delta x plus delta y minus delta x, as dy by dx is equal to delta dy by dx delta x by delta y is equal to dx by dy is equal to delta x by delta y. This implies that delta x is equal to dy by dx into delta x. So if we put the value of delta, yes, now by the principle of calculus, dx by dy is equal to delta x by delta y. So finally we calculate delta y is equal to dy by dx into delta x. Now putting this value of delta y in equation third, then we get delta y is equal to dy by dx into delta x. This is the equation number third. Third equation gives the change in volume, so volumetric strain due to the propagation of sound through the medium is just calculated as volumetric strain is equal to change in volume by original volume. So it can be written as minus dy by dx into delta x by delta x. Finally it can be written as minus dy by dx. This is equation number 4. Again, this volumetric strain is due to the pressure exerted on the transverse layer of the tube. So if pressure is just given as P in this side and P plus dP from this side, then in the direction of right, the average pressure is just calculated as P average is equal to pressure plus change pressure divided by 2. This can be written as P plus dP by 2, and this is a small, so it is equivalent to P, and P can be written as force per unit cross sectional area. This is equation number 5. Now, if volumetric strain is due to this pressure, that is this result will come due to the effect of pressure. This is due to the effect of pressure, and now property of medium, that is elasticity, elastic property of the medium, elasticity is just calculated as stress by strain. Stress by strain, so it is just written as P. Stress is equal to P, that is force per unit cross sectional area, and strain is equal to delta V by V. So this can be written as P dy by dx. This can be written as pressure is equal to E dy by dx. This is equation number 6. Now, 6th equation represents the pressure in terms of elasticity of the medium. This is equation number 6. And again, if we consider the effect of pressure, now this is dy by dx is the term as the volumetric strain, so it can be written as with minus sign. Now again we consider the net force on the tube, so we calculate the net pressure. First, we calculate the net pressure on the tube in the gaseous medium. So net pressure P net is equal to P along the right direction. Along the right direction, that is along the direction of propagation of sound. It's just written as delta P, due to which this is equation number 7. And due to this pressure, net force is just calculated as, for the unit cross sectional area both are same, so it can be written as delta P from this equation, that is from this equation it is very clear, delta P is equal to dP by dx into delta x. So delta P is just taken here minus d by dx of P, that is P will come from equation 6, that is E dy by dx into delta x. This is equation number 8. This is a required equation of net force acted on the imaginary gaseous tube due to propagation of sound along the right direction. So as per the Newton's second law, we can also calculate the net force acted according to Newton's second law. Net force is calculated as net force on the gaseous tube is calculated as rho into delta x. This is the density multiplied by volume. This is called mass, and displacement is again differentiated, then it will give acceleration. This is called equation number 9. On comparing equations 8 and 9, we get d2y by dt square is equal to E by rho d2 y by dx square, and this can be solved, this equation 10 can be solved with the value, constant value c is equal to root under E by rho, and this is equation number 11. This is required equation of velocity of sound wave through the gaseous medium, where E is the elasticity or elastic property of the gaseous medium and rho is the density of the gaseous medium. And finally we explain that property, property like elasticity and density gives property like inertia. If the gaseous medium have not such type of property, then sound cannot travel through it. And finally we can write velocity is directly proportional to E, that is velocity is directly proportional to elasticity of the medium and inversely proportional to density of the medium. Rest is okay. Good.